Hello guys, my name is Malhar Sagara and welcome to this PCB making tutorial. I'm an avionics member in VRT and today we are making a power management board for our model rocket Noah. Now this PCB will have multiple voltage rails. It will also have our battery monitoring system and it will give different voltages to different subsystem as per their need. So let's first make a schematic diagram. And here we are at EasyEDA website. We will click on Design Online and we will use the Pro Edition. So here we are. I've already logged in and we will make a new project and we'll name it Power. So here we are. Here we will choose schematic and we will get this sheet in front of us. So now let's first get all our components here. We will go to place, then device. The first thing we will have are the buck converters, which are nothing but DC to DC converter, which will be used to give different voltages to different subsystems. Now we will need three types of voltages: 3.3 volt, 5 volts, and 7 volts. For the 3.3 volt, I am using PPS 562209 buck converter, and here it is. We will choose place, and here it is. We will place it here. And for the remaining two, I'm using PPS 563209. We will place it again, and here it is. Now we will place our microcontroller, which is ESP32S2 room. Here it is. We will place it here. We will change the sheet to A5. Okay, sorry, to A3. Yes. So we get a bigger sheet. Then we place it here. Yeah. Now we will put our P-type USB, which is GT USB 7010 ASV. Here it is. We will place it here. Now we will need a voltage regulator to connect between our USB and microcontroller, which is TLV 76733 TRVT. Here it is. We will place it here. Now we will be needing switches for boot and reset, since we are using an assembly version of MCU on the microcontroller. So the switch we are using are PT S645 SH 50S MTR 92LFS 92LFS. That's quite a big name. Here it is. We will place two of us, one for boot and the other one for reset device. Now we will need 2 to 3 different diodes, which will be used during the connection of our USB with our microcontroller. So the first diode is ESD 341 DPYR. Here it is. Place it near the USB. Now the other two are ESD 321. So we'll just replace the 5 with 2, and here it is. So we have almost everything. The last thing we need are screw terminals, which will help us to connect the other systems to our system through wires. The screw terminal we are using are DB125, 3.81 to PRDS. We will be needing so much screw terminals since we have so many outside connections, like since we are getting output, so we need many screw terminals. I think that's enough, and we will need more for the pyros So just select any screw terminal like this, and we will copy it by Control C, copy successful, and we will do Control V. Here we are. I will place my pyro schematic here. Okay, so we have almost everything. For the battery monitoring system, we will be using a voltage bridge or voltage divider, which will be made through resistors. Now we will be needing some passive components like resistors, inductors, capacitors, which we will take from here, the common library. Here it is. So we have resistors, capacitors, diodes, transistors, connectors, which are nothing but screw terminals, switches, and all. It does have inductors. Okay, so we will be taking passive components from here whenever we will need them. So, okay, so let's start. First, we will go here. Now to rotate this, we will select it and we will press the space bar 2 times. So it is rotated 180 degree. This will be our battery connection, main battery connection. So we will change name. From this to active. Now we will bring a wire from here, and for that we will click Alt plus W. As you can see, I've got a new cursor or something like that. Now when I click here, a green line comes out, which is nothing but my wire. So yes, here this one, and then I will right click. So this much I have chosen. I will name this so we will use the net labeling method for the connections, which is nothing but like putting a label here on this part, like net 1. See how I did this? I went to place, and here there was an option net label. I clicked it and I got a net label. Now we will name it as um, bat v in. So as you can see, I've named this connection between. So now whenever I make or tear out a wire like from here, and now if I press Alt N, I've got a net label. This is a shortcut, very much useful, and click it here. Now if I name this net label the same as battery in. These two are automatically connected. So this is why net labeling is very much useful. It makes our schematic look more clear and tidy instead of wires going around from here and there. And we will put the ground, which we will select from here. Here it is. Now to connect the ground, now to rotate, we will press spacebar and it is rotated and we will connect the ground. Let me just stretch it out. Yes. Here, battery will be connected here. This is the positive terminal and this will be the negative terminal. Now let's go to our buck converter and how we will make its connection. So for our buck converter, we will need some passive components which we will take from common library. The components are capacitors, so let's have them. We will be needing 3 input capacitors, 3 output capacitors, and another capacitor. So in total we will be needing 7 for one buck converter, 7 capacitors for one buck converter. We will also be needing few resistors. Here it is. And we will be needing inductors, only one inductor. Here it is. Let's place it here. I want to change its footprint, so I'll select it. I'll go here, footprint, and I will change it from here to NED SND L5.0 W5.0, and here it is. I will update it, and we have changed the footprint of our inductor. Okay, so let's start the connections first. Put the resistors aside, the inductor also, and put this guy's aside too. Bring this here. Now, first we will rotate them like this. Now, since these are the input capacitors, what they'll do is they'll smooth out the ripples which come from our battery, and the output capacitors will smooth it further for our subsystems. Now, in a buck converter, There's um, there's a MOSFET which acts as a switch, and it turns on and off very fast to regulate the voltage. What the inductor does, the inductor here helps us to store and release the energy. So whenever the MOSFET is off, the energy is provided by the inductor. So let's start with the connections now. Here is the V in, that is voltage V in. We will press Alt W. Here we have the wire cursor. Click here. We will bring out a wire, and it's still this. Now we will press Alt N. This net label, we will place it here. We will name it battery V in, because the battery will be connected directly to the buck converter through the input capacitors. Let's name this first as buck 3V3. We will place this here on top of it. Sorry. W, Y goes down here. We will label this as SW1. Sorry, it's just SW. We will name it as SW1. Enter. Now this is GND, so we will place this ground symbol here, and we'll bring a wire. Now we come to this side. We can also just, as you can see, we can just click or right click this terminal, and we will have the wire symbol with us, and we can just bring out a wire like this. Now Alt N, and we will label it as VPST. Now you may be wondering how I know the connections. So I have checked the data sheet and all, and in that they have given the connections and everything. Now here we will take a wire, and from this I will bring one resistor, connect it. Sorry again. From here, just label it as EN1. Now from here how the connection will come. We will use two resistors. These are also called feedback resistors, like this. We'll bring a ground symbol, we'll connect it here. And from here, I'll bring a connection and I'll label it as 3v3. Now, you may be wondering what is this SW1, VBSD, EN1, 3v3. You'll get to know in a short time. Now we will connect these passive components with the buck converter. What we will do is we will bring the inductor like this. Yes. Now from here we will take a wire and alter and we will label it as SW1. So this part is connected to the inductor here and alter W. I want a connection between here. A capacitor is connected here and from here I will bring the connection and we'll label it as VBST or bootstrap voltage. So here the connection is done from here to here. Now we will just bring a long wire from the inductor like this and the output capacitors will just be connected in between like this. 1, 2 and 3, and we will label this part as 3v3. So the voltage output will come from here. It will go to the other systems through this screw terminals, and it will also go to the buck converter, which will it will be feeded back to the buck converter through this. So just a minute. We will bring a wire from here. We will label this as 3v3, that is the output the positive terminal of our system will be connected to this wire and the negative terminal will be connected to ground. we are having at least three output of every buck converter. Three V three. So this is how we've done the connections of our buck converter. We have done one buck converter. This same type of connections will be done for the other two buck converters, which we will do later. Okay, here I have done a mistake. I forgot to connect the other terminals of the capacitors to ground. Okay, now it is done. Now we've done the 3v3 buck converter. Similarly, we will make such connections with the other two buck converters. We will also be using a MOSFET, which will act as a switch to the cameras that we will be using in our rocket. So to power the cameras and to do it safely, we will be using a MOSFET, which is A03400. Okay, so it's not A0, whether it's A4. Yes, here it is. We will place it here. Yes, two MOSFET. As you know, MOSFET has gate, drain, and source. So the gate will be connected to the microcontroller, any of its GPIO pin, which will control it. The drain will be connected to the screw terminal, and the screw terminal will be connected to the terminal of the camera, and the source will be connected to ground. We will also be using fuse, which we will add later. So now let's start the connection of our USB. So let's start the connections of our USB. First, we will ground the wherever it is needed. We will connect the ground symbol with all the shell terminals will be grounded like this. Yes. Now we will connect ground here. like this, and a ground here, like this. Yes, let us get this diode away. Now we will start our connections from here. I will take a wire out. I will label it as V red because this will go to the regulator, and we will connect one of our diodes here, like this. We will connect it now. We will also be needing some resistors. So yes, four resistors. Now from this CC1, first let me take all these resistors and put them aside, like here. Now from CC1 onto W, from CC1 I will take a wire and like this, we will connect it with a resistor. Now from this DN2, I will bring the wire like this, like this, here, yes. We will label this as USB D minus. Yes. Now we will bring this diode and we'll connect it here. We'll bring ground, rotate it. Here we will connect it to the ground. Now we will need a resistor between these two. So what we will do is we will just bring this here, and in between we will connect this resistor. So I just placed it between on the wire, and it is connected like this. Now this DN1 will be connected here like this, and from this DP2 we will bring out a wire, same as we did with DN2. Yes, and we will label this as USB D plus. And now we will connect our last diode here, and we will connect the resistor here, ground. Now this DP1 will be connected here. From the CC2 we will bring down a wire like this, resistor, and we will connect the resistor. And from this V bus we will bring a wire and we'll label it as V right. So the connections of the USB is done. Now we will move on to the connection of the voltage regulator and the microcontroller. And from this you will be clear about this VRAG one and the USB D minus and D plus labels, because USB D minus D plus will be connected to the USB also. Oh, sorry, to the microcontroller. So now let's start with the connection of the voltage regulator or LDO. We will first rotate this like this. Yes. We will first connect the ground. Yes. In this in from this end, I will bring out a wire, and now we will label it as VRAG. Yes. So we have labeled it VRAG. Now from this EN, we will connect it here. Yes. And this EP, this will be connected to this wire, but through a capacitor like this. There's another ground, so we will ground it. Sorry. Like this. Now this 3v3 of the microcontroller, I will bring the wire out. This will also be connected to the buck converter and to this voltage regulator too. So we will first label this as 3v3. Then we will bring out a wire and we will connect this here. This FB or an SNS, this will be connected to just like this. Yes. And we will need a capacitor. We will connect it here. And last thing is the ground. Yes, it is connected. So this is also done. The last thing we will the not the last thing, but now we will do the battery monitoring system, which is nothing just a pair of resistor like this, and we will just put them here like this. This from here. This will be connected to battery in, and from here this will be connected to the ADC pin or the analog to digital converter pin of the microcontroller. So we will label it VADC. Yes, and we will connect this. This is nothing but a voltage divider like this. So this is a simple battery monitoring system. Now the ADC pin is the IO4 the microcontroller. So we will bring out a wire like this, alter N, and label it the same VADC. Yes. We will use GPIO 20 as USB D minus and GPIO 19 as USB D plus like this. Let us connect the ground to the microcontroller. So we have done it. Now we will see how we can do the connection of the switch. So let's start with the connection of the switch. We'll first connect these two terminals like this. Then just two terminals like this. And from here we'll bring another wire. We'll label it as boot, and from here I'll topology to take a wire from here. So we take a resistor, connect it, and this will be connected to TV3. Now we will be needing ground. From the ground, ground will be connected here. And similarly, we will do the connection of the reset button. So we have done this. This are for pyros. So let's do this. Another battery will be used for pyro. So this will be labeled as pyro in, and this will be ground. So let's bring the symbol and connect over here. Yes, these two are the screw terminals for the pyros. Here, the pyro in. Here also, sorry, pyro in. And the remaining terminals will be grounded like this. So we will do the remaining connections, and let me show you how the end result will be looked. I will name this PCB as IGRIS, and hence I will change the name from power to IGRIS. So let's do the remaining connections. So this is how the whole schematic diagram looks after completing all the connections. This is our regulators. These are our regulators, buck 3v3 and all. This is the 5-volt buck converter, and this is where the cameras will be connected, and hence I've used this fuse and this MOSFET. This G1 and G2 Net labels are connected to the microcontroller here, G1, G2, which are nothing but gates. This is connected, the drain is connected over here, and this source is grounded. Similarly here. Then I've used two LEDs, and this small screw terminals is for the SD and SCL connections with the communication computer, which will also be attached in the rocket. So this SDSCL are of the microcontroller, which is here SDA SCL. So that's all about the schematics. I hope you learned many things. Hope you liked it. So thank you, and we will move on to the PCB making of this. For that, we will go to layout, not layout, sorry, design and update or convert schematic to PCB. Also, I forgot to tell you that this EN1 will also be connected here. Now, this symbol is for short because we have already used one net label, we can't use another over here. So we have to use this symbol, which means that we have taken another connection from here. So yes, that's all. Now we will move on to PCB layout. So let's start PCB layout. We'll go to design, update or convert schematic to PCB, and apply changes. Here we are. These are all our components with their footprints. Now I will make a border border outline, which will be rectangular of 98 by 60. Okay, here the dimensions are in mil. So let's first change it to millimeter. Now I'll place border outline rectangle, and so we will make it of 90 by 80. 90 by 60, sorry. It will be very small, like this. 98, I think, yes, 98 by 60. This much. We'll zoom it. Property. Now here I can just change the width 60 and height as 98. Now what I did was I first went to properties, this, then I selected this purple line and I got its property here, width and height, and I changed it. Now I want to change the corner radius to 5 mm, like this. I want it to look like this to add some style. Now first we will put this holes here to stack the PCB, or yes, to stack the PCB. I have chosen it from here, this pad. Now we will place it anywhere like here. Now to center it or to bring it in center, we will do Alt M. Here we have a measurement tape. From here, I'll measure it. Listen, wherever it will snap, that will be my center point. So it is snapping here like this. See this snap. So the distance is 1.350 to the left. So what I'll do is I'll click on this. Then here it is. Here are its property. Then this center X, I will just do minus 1.305, right? Just cross it. Now to check if it is in center, we will do Alt M, and from here going. So yes, I think it is. Now on the y-axis, let's see. This is where it is snapping like this, which is so the response is 0.715 upwards. So we'll change it here plus 0.71. So I've done some mistake, I think. Here it is. And we will just go plus 0.715. Now to see if it is centered or not, we will, yes, so this is centered, I think. And this is centered, and on the x-axis it is centered, yes. Now this is how we center our pads. Now the first thing that we will place on, on this board will be our microcontroller, which is here. Take this here, bring it a bit down, this, yes, and we will place our USB here, slightly in front of our microcontroller. So we have placed this. Now we will place our battery screw terminal, main battery screw terminal. Now instead of finding it like this, what I'll do is let's search option. I'll do Alt S. Okay, it's not closed. Now control. So we will do shift plus F. Here it is. Oh, okay, it's not shift plus S. We will do control plus F. So here we are. Now we want to find factory. So here it is. Yes, you will bring it over here. Now what I want to do is I want to bring all the two terminals on, on the bottom side of my PCB. So for that, what we will do is we will press on this and we will do Alt B. And as you can see, this is in the bottom now. This green lines indicates that it is in the bottom and we are on the bottom layer. Now one more thing, we will go on, like we were here on the properties, we will go on layer and on this common default. Okay, this is common. We'll go to this option and we will do copper layer 4, one signal, two signal, like this inner one will be signal, but this bottom one or the top one will be, and we'll do it later. So to get back on the top layer, we will do Alt T. Yeah, back in the top layer. Let's bring this a bit down. Like this too. And this guy also. Yes. Now we go to here and I've changed it. I did it 4 and this inner one 2 was signal and then I changed it to plain zone. Yes. And confirm and it is applied successfully. Now we will place the 3v3 screw terminals which are here. I will first bring them in a line, then select them, then bring them together up like this. And yes, now I will place the screw terminals here and Alt B like this. Yes, this one here and Alt B, this one here, Alt B, yes, like this. Okay, now we will place the 7 volts, the 5 volts one. Here they are already in a line. So what I'll do is I'll select them all like this and then bring them up and see how they all work together. Now what I'll do is this U16 and U17, these two are for cameras, so I'll put them here like this. This. Alt B, space space, enter B, space bar, just like this. Enter B and space. This guy will come here. Enter B, space. I think I have to put this down a bit more and just bring it here. Enter B, space bar, yes. Now let's do the 7 volts. Two terminals. Here they are. And Enter B, space. Put this one here. Enter B, space. Enter B, space. Yes. So these three are also on the bottom. Now we will do the pyros lastly. And here they are. Yes. This will come here. Space. Enter B. Enter B. Enter B. Enter B. So we have put all the screw terminals. There's one remaining, which is of STA and SCL. Here it is. Let's place this one also here, like this. And let's put it there. Alt B, and yes, there it is. So we have placed all of them. Now we will do the. I'll show you the routing. Let's get on the top layer first. I will show you the routing of the USB with its specific components and with the microcontroller, and we will get to know about differential pair routing. So we will first put the diodes at the bottom of the USB. Let me show you. To control that, and I remember U6 was the number of one of the diodes. Here U6, we will be needing U6, U7, and U5 here. what was that? So here we are. Now we will bring this U5 over here, yes, like this. And what we will do is we will place this on the bottom by under B. See, here it is. And get to the top layer. And we will bring this one also here to the bottom, and this will also go to bottom like this. Let me change this like this. And, well, we can change the size of this font, like from here to, let's try 1 mm. No, that's not enough. What about 0.5? Let's do 0.5. Okay, I think that's fine. We'll place it. Bring this over here. U5 will be here, and U6 will be here. So let's change the height to 0.6. And we will change the height to 0.6. Now, what we will do is we will connect this VRAG to here. But before that, let's just connect this D minus to this D minus. Now, so for connecting this to, we call it routing, and for that we will press Alt W like this, and we will select this and see this is the wire coming, and like we can control it like this. But now the problem is, since our component is in bottom, we cannot directly connect it here. So what we will do is we will put a vias here. What a vias will do, it will connect the bottom layer, sorry, it will connect the bottom layer to the top layer. Now to put a vias, we've got, sorry, we've got two options. You can either do Alt V Press Alt V like this, or we can go to place and a VR and add a VR over here. Now what we will do is we will place this VR over here, like this. Yes. And now I will do Alt W. I'll bring this wire and I'll connect it with the VRs like this. And now I will go to the bottom layer like this. Oh, sorry. We have selected the whole USB. Sorry, guys. Yes. Now we are in the bottom layer. Let's go. Alt B. We are in the bottom layer. Now from the like, Alt W. Wire comes from this and this connected over here. So now these two are connected through this VRs. Like it is a hole in which the through which the bottom and the top layer are connected. Now what we want to do is connect this D plus to this D plus, and for that what we will do is Alt W, Alt W, we will bring a wire like this, like this, and we will put VRs over here, Alt V, here it is. Now we will get to the top layer and just connect it over here, like this. As you can see it is connected. Now we also have to connect this D plus to here and this D minus over here. For that what we will do is we will put a VRs over here, and in the bottom layer we will connect this two, and then on the top layer we will connect this with this, and this one will be connected like okay, so I think I have to change the position, the VRs. Oh, let's do that. Let's get on the top layer, do the VRs like this. And now we bring, okay, no, we cannot. Let's bring this VR over here. Okay, let's change this like this, like this. This will give us some space, as like this. And now, if we bring the wire, it will like connect here like this. Yep. Yeah. So as you can see, we have done this. This is called routing, and this is how we will connect most of the components. Now let's get to the main part, which is differential pair routing. Now, whenever we connect a USB with the microcontroller, the USB pair or the connection which contains the USB uh, connections, we call it differential pairs. Like this D plus, D minus, D plus, D minus. These are differential pairs. So we have to route it in a different way. And for that, we do place and okay, it's not here, I think. Well, it can be done from here, I think. Yes, this is single routing, which is normal. What we do is single routing. Yes, from route, we can do differential pair routing. And like if I click over here, no differential pair, we want to create differential pair. So yes, we do want to DP1. So the differential pair that I am creating is DP from DP1 is D plus, and over here I want to do D minus and apply. And I also want to make another one DP from DP2. Oh, sorry, we have to go over here, add here. We will do DP2, and the positive net will be USB D plus, and the opposite one is automatically there. So apply, confirm. Now it is applied. So what we will do is so we will take it from here and you'll go like this. Uh, yeah, I've done a mistake here. Uh, we have to put two resistors which we use in the schematic, which are we can always refer to the schematic. These two are 15 and 16. So let's get back. Are 15 and 16. Control F. This is R15. Enter, and this system has found it. Here it is, and here is the 16 one. So 15, 16, we need both of this. So like this. So this will come here, and this will come over here, like this. Now, if we do Alt D, we've got this symbol of differential routing. And now, when we start, we will first connect them like this. Yes, like this. We want this green thing And now from here, uh, as you can see, the match the rule. It is something that EasyEDA have in its own system that whenever it makes a PCB, there are some tolerances and rule that we have to follow so that it makes them easier to manufacture. So we have to stay in this green area, and yes, here it is done. We have connected. So here we have successfully done differential pair routing, which was one of the main thing. Now we will make a buck converter, like we will do routing of a buck converter. So let's bring the 3v3 buck converter over here and all its passive components, and I'll show you how we do it. So for the 3v3 buck converter and its few terminals, we will create a region over here, which will be a 3 volt 3 region power signal, power region. Like that specific region will contain 3.3 volts, and it makes easier for us to get and manage different voltage outputs. Let me show you how we do it. We go over here, we select polygon, and from here I will make a polygon, anything which looks like this. Yes, like this. Yes. Okay, fine. Sorry. Now we will, yes, this will be a corporation and we will name it 3v3, and it is on the top layer and the net is 3v3. Yes, let's confirm this and we will rebuild copper region. Yes, see, as you can see, this whole region is now 3v3, and as you can see, this like it is connected. This 3v3 are connected here. Now let's do some fixing here. Like I want to bring this over here like this, and I want to get it straight. So I think this will help us like this, like this. We'll fix it later. So this is our preparation. Now let's bring the buck converter IC and all its specific components of 3v3. Let me see. Yes, here they are. So here is the buck converter R1. R1. R3, R2, this inductor L1, C3, the C5, C6, C7, and this two guys. Yes, now we will select this hole and we'll take them up like this. So let's start. Let's put them aside first. Now, the first thing I'll do is I'll put this over here like this. Bring this here. Put it like this. This here. Sorry. Then let us first connect this with this SW1, and there's a resistor, capacitor, sorry, connected between this, which is C4 capacitor, which is not here. You have to bring C4. So let's do this. Here it is. Let's bring this up quickly. Here it is. So let's zoom a bit. Bring this here. This C4. You come over here like this. Change the font size. Now what I'll do is I'll bring it here. And all this aside. So there's some space over here. Now we will do routing, which is Alt W. From here we will go like this. And from here we will go like this. We have connected this. This VBSP will be also connected over here like this. Yes. Now we will bring this here. Always remember, guys, that when you're doing routing, this angle between this turning of wires should never be 90 degrees. It should always be less than or more than 90 degrees. Like here, like that should never be 90 degrees. It should never be 90 degrees. So let's put this here and mark it down. C3. Oh, sorry, my mistake. We wanted C1, C2, C3. Here they are. That's C1. Here it is. And we will put it like this. Like this. So this will come over here, this will come over here, this on top of this three should be over somewhere here. Yes, that's good. Now, I'm not connecting this battery into directly to this battery because what I'll do is I'll make a whole, like make this whole PCB, all the remaining like areas in like the power region of battery in, so that I don't have to route so much and make it a mess. And on that between on that battery V in region, I will have this smaller regions of 5 volts like this 5 volts, 3v3, 7 volts, one region of pyro like that. I'll show you once we get on. So let's bring this R1 over here. Let's put one. This will be here, and I'll route this part right here. This, yes. Now the remaining three capacitors will be over here like this. These are the output capacitors. And now we have these two resistors, the feedback resistors, which are over here. Let's connect these two since they are not labeled as 3v3, yes, like this. And this will be connected to this, like this. As you can see, this 3v3 of this inductor and capacitor and this resistor are still not connected to this region. For that, what we will do is we will select this region and we will do rebuild copper region. And it will take some time, but see, it is rebuilt and these are connected. It has also made space for the wires like this. So we have done connection of one buck converter, and this is how we will do the connection of the other buck converters. Let's first make a region of bet V in like this. I will select the polygon and let's make it rectangle this time. Like this. Yes. This is copper region. The port name will be bet V in. Oh, wait a minute. I forgot to change it. Net. Its net will be bet V in. I will do rebuild the copper region, and as you can see now, see now this bet V in is connected to this, and through this it is connected to the buck converter's bet V in. So this is how we do it. Now if I want to make a region of 5 volts over here, I can do it like this. I'll go over here and I'll select polygon, and here I'll just straight like this, click down like this, click down, click, and see this port name will be 5 volts like this. This top layer and the net will be 5 volts. Confirm. So this is the 5 volts. Now as you can see, there's a gap between battery in region and the 5 volts region. Similarly, we will make a region of VRAG over here like this, because the USB will also give power, and Hence, we are making a region so that we don't complicate the routing. Yeah. Okay. 4 is VRAG, and this will be VREG. Confirm. So we will now make a 7-volt region. I think what we should do is we should get to the bottom layer, bring this a bit down, bring this a bit down, and bring this a bit down. Then we get back to the top layer, select this polygon. Then from here, I make a region like this. Yes, that is done. This will be 7 volts, and the net will be 7 volts. We confirm. So we have made this region also. Similarly, we will make a pyro region, and we will do the rest of the connections here. Now let me show you how we will connect all the grounds. Like what we will do is we will select rectangle, and we will make a big rectangle like this. This will be G and D 4 instead of 4, and this will be G and D. This will be on the bottom layer, and yes, this is ground. Confirm. As you can see, there's ground over here, and now if we do rebuild copper area, it is done. For this, we will do rebuild copper area, and this is also done. So this is how we select, like we make different regions for power, signal, and ground. Now there are some places where I'll have to connect ground manually, like by routing, and we will use VRs over there. Now since it is on the ground, I'll have to use VRs. So let's bring some components over here and start doing routing, and I'll show you the end result directly. So guys, this is the final look of the PCB. I have changed some regions, the lengths and all, like here. I've changed the region, I've changed the names to make it more clear. And I've added this pad, which I just added one before, and I showed you the routing and all. Here is the MOSFET and fuse. I've connected the gate of the MOSFET like this from here, sorry, from here like this. This blue line represents that it is on the bottom, and the red lines represent that it is on the top. Now for the ground, as you can see, what I've done is see, here was the ground. I've put a vias and named it ground, so it directly connects the ground layer to this red wire, and I've connected all this like this. The SDSCL are also connected. These are the switches, the boot switch, and this is the reset switch or button. This tab is opening because I have locked the objects. So confirm yes, I can move things. Okay, like that. This is the 7-volt regions. This is the 7-volt bus converter. Here is the USB, and this is this region, particularly this region. This is the VRAG region, as you can see from here. This is the voltage regulator. Half of its part is in the VRAG, the other part is in the other region. These are the LEDs. Here is the 5-volt region, like 5-volt buck converter, and the 5-volt region. This one is the 5-volt region. I've connected fuse and MOSFET to this camera screw terminals. Camera screw terminals. As you can see, there is not much routing in this PCB, but I hope you have learned many things. Like you've learned how to do schematic diagrams, how to connect components in that, how to get specific components from the common library and all. In PCB, you have learned how to do routing, how to make a border outline, how to make a region, and also how to connect things like how like alter W for wire and all, how to label things. You have also learned how to switch between top layer and bottom layer. Most importantly, you have learned differential pair routing, and I guess that's all. I have made this. I have named this PCB IGRIS, and I've made this text named IGRIS, which I will. It is in the bottom layer, hence it is like this, and it is also mirrored. So I will put it here, IGRIS, and another line, precision, power, and performance. This is all to style the PCB. This is our nice little PCB. You also know how to center the pads, like all this basic things. See how I've connected this ground. We have also connected all the grounds here also. One last thing that I forgot to tell you in the schematics was this. Any pin which you are not using, you put a cross over there. You don't leave it floating. It's mandatory to do. You should not leave it floating like this. This was our schematic. This is our PCB. Now let's see how it looks in 3D. I Let me just bring it back on a better place. Yes, to get into 3D, there's this 3D preview option. If I choose this, it will come in 3D, and voila, there it is. See, beautiful, isn't it? This is our microcontroller. This is USB, two terminals, all the passive components, buck converters, buttons. So yes, that's all. That's how you do routing. That's how you make a PCB. And thank you.